So let me, again, just look at the whole concept of feathering. Here are my two images. What I can do is I can take, and of course we would be doing this at the frequency spectra for each and every one of the octaves, F1 and F2. Here I'm showing it in the spatial one. Imagine if I was to take this signal like this and do a computation as we've done here before. Again, remember these are just step functions of different types. Of course, you'd see a sharp boundary. So one way to do this would be is I can blur the sharp boundary. So I can run some sort of a blur kernel on these two band images here. So this would actually make this area be not just a sharp step, but a ramp between the two. So that would be the output here. And if you actually use this just for feathering between these two images, that's what the output you'd get. So now you actually see there is blending going on, but it's much smoothed out because of the fact that this is no longer a sharp function. Of course, the important part to remember is we want to do this at each and every different octave. So bottom line is, in doing this process, we basically can smooth out the images because in essence, doing this blurring and all the entire process of feathering makes the blend smoother. So recall again, what I'm really interested in saying is we want to do this feathering, but we want to do this for the corresponding octaves. In the Fourier domain, we want to compute the inverse Fourier transform. And this basically allows us to do this by summing the different types of octave images in frequency domain and allow us to generate a smooth image.